So I know that there are 4 or 5 parallel sessions going on right now, so thank you for your interest in this session. My name is Bithika Khargharia. I am a principal engineer at Extreme Networks. I'm also the director of product and community management at the Open Networking Foundation. So with this panel, we are essentially discussing 4 different projects that are funded and hosted by the Open Networking Foundation by ONF. And these projects we are talking these projects here because they are really adding value to the OpenDaylight project in their own unique ways in a variety of network domains, in a variety of different use cases, as well as interoperability in the northbound and southbound. So before we get started, let me just quickly introduce the panelists. The far right is Karthik Setu Raman. He is SDN and software architect at NEC. He's vice chair of ONF Open Transport Working Group. He also co-leads 2 different open source ONF open source projects. One is Project Snowmass, and the other one is Project Englewood. And among other things, Project Snowmass, what we're going to discuss today, they are essentially bringing SDN into transport networks, and they're providing an effective mechanism to do SDN on multi-domain, multi-layered transport networks. For example, managed by ODL, ONOS, or any proprietary NMS. Right next to him is Gerd V. I can't say his last name, so it will just be V for now. Gerd is Principal Enterprise Architect with Microsoft IT. He also serves on the customer advisory for Project Atrium Enterprise, which is co-led by Dave Lenrow. And with the help of Gord and his advice, we are building an open source solution on ODL to address typical enterprise pain points in unified communications and enterprise WAN offloading. Right next to Gord is David Lenrow. Dave is Chief Architect and Distinguished Engineer at Huawei SDN, and he co-leads Project Boulder and Project Atrium Enterprise. Dave was responsible for kicking off ODL NIC, the Network Intent Composition project, and now with Project Boulder, he is taking the same intent model to a controller agnostic layer. Finally, we have Martin Skorupski. Martin's a system architect with High Street Technologies, and he leads the Project Centennial at ONF Open Source. Centennial has performed many successful POCs of the ODL controller for mobile backhaul, specifically microwave and millimeter wave networks. So you see the variety of network domains and use cases that we're addressing here with these 4 different projects. So with that, let me just kick it off. So what I want to do is first talk a little bit about what are the real world challenges essentially that your projects are working on. If I could ask Karthik to start off.
Thanks, Bithika. So with transport networks, we are talking 2 main things, at least for our project. And the first one I just like to call like integrated control of transport networks. And by integrated, like there are various dimensions. First is multi-layer, so integrating packet optical control, packet networks and optical networks. And by packet, it could be IP MPLS, carrier Ethernet, and optical could be like OTN, it could be OCH, optical layers, WDM, and so on. So that's one level of integration. The second is multi-domain integration. So by multi-domain, again, in ONF, we sort of had a more generic definition to a domain. It could be vendor domains, it could be administrative domains, it could be operator domains, right? So these are this multi-layer and multi-domain is one of the key features. But also like something we have to consider, which was not there for like when typical data center SDN or enterprise SDN is integration of legacy networks and the SDN networks, because in transport domains, as we all know, the end of life for these products are like in decades, like maybe 10 years, 20 years. And no operator was willing to, or no vendor was willing to throw away his existing network or existing network elements for an entirely new SDN enabled devices. So one of the challenges we had to address was brownfield. I mean, that was higher priority for us than greenfield scenarios. So again, there's integration of brownfield, looking at multi-domain, multi-layer. So overall, like I'm putting it all of this into a category called integrated control. The second thing for us, like one real world challenge was in transport domains or in transport area, we had a lot of standards. I mean, we have a lot of standards and they're very good standards, right? And the question was, are the standards being implemented and what is the real roadblock to these standards being implemented in reality? So what I would like, I coined this term like more, we always talk about standardization of software. I'm saying softwareization of standards. And by that, what we mean is in Transport API, the project we did, we leveraged the existing standards. We didn't go and try to define everything from scratch because we had a lot of maybe like 20 or 30 years of experience in the standards. We had folks who had like 40 years in background in doing standardization. We took that, and as I'll talk later on, we put it into a softwareization agile methodology, tried out POCs and tried out in recursive fashion, tried out different softwares, SDKs, and then fed it back into the standard. So I would say more like these are the two main drivers for us, at least real world problems we had to solve.
So we're focusing in Atrium Enterprise on a initiative that we call inside Microsoft IT as Internet First. So that we have 3 high-level strategic initiatives. One is deployment of IPv6, second one wireless, and then third one is Internet First, which we are addressing today. So in the past, we've been a very traditional deployment, or we have used a very traditional deployment model using MPLS, lease lines, etc. for WAN. And that has been the logical choice because we see that all the workloads typically was sitting in our data centers. We had requirements from our security teams where they asked to be able to monitor every single packet that leaves the network to internet, et cetera, et cetera. Now, the last years, just like every other company, we've seen that workloads are moving out of the corporate data centers. They're moving into the cloud. So this can be corporate applications like Exchange Online. It can be Office 365. There can be numerous things. It can be applications that are custom made, but that still move to Azure. And secondly, we also got a little bit more relaxed requirements from our security teams that allow us to kind of drop traffic on the internet without being able to see every single packet. So if I take the example of myself, as my name kind of explains already, I'm based in Europe, in Belgium, so my breakout point for the internet used to be in Dublin, is still in Dublin today. So if I go to any of the workloads, or it can be any other internet traffic, it can be Facebook, it can be Netflix, it can be YouTube, that traffic is transferred over a corporate network to Dublin, breaks out on the internet, and at that point in time, it finds the closest server. So that doesn't make a whole lot of sense because there's not really added value, right? Even to give an example that kind of explains it a little bit better, if I'm in Amsterdam where we have an Azure data center, if I want to access my mailbox, I can Exchange Online, it might be sitting down the street from me. So today my traffic goes up to Dublin and then it travels all the way back over the internet to the building down the street. So that's not really an improvement of the user experience. And so with Internet First, we drop by default all the traffic on the internet in the local office at kind of the edge of the building, except for some flows that we are not able to do that with. And there can be a number of reasons. One of them is quality reasons, so it can be Skype voice or video, which for reasons of jitter, packet loss, delay, etc., we still need to transfer that over a link that we can control. It can also be for certain security reasons, so these are mainly like engineering workloads or like batch readers and stuff that we do not, or that we cannot drop on the internet, or that we're not allowed to drop on the internet. And thirdly, it might be just for functionality reasons. Right? So that's the whole idea behind the Internet First. The goal is that we can really, we won't take away the corporate connections that we have today, but it's going to dramatically be reduced in size, and it's going to be dramatically reduced in costs, right? Definitely, if you look at emerging countries, the price of a 400 or 500 megabyte circuit, if you can bring that down to 1/3 of that, 100 megabyte, that's a substantial saving that we can realize. Okay, so that's the use case that we're looking at.
Thank you. So. In Project Boulder, initially the idea was to take work that we've done in the NorthBound interface group, and by the way, I will announce that yesterday at noon, I believe, we officially finished the review period, and the operating principles of intent-based systems document is now published as an ONF technical recommendation. Based on the description of an intent-based system and the definition in that document, we're now trying to build a common NorthBound interface based on that on multiple SDN controllers. And so obviously, ultimately, we'd like this to be the common interface for all SDN controllers and kind of the narrow waist that allows you to build things on SDN controllers without having to, get very specific to the particular SDN controller. And so ONOS and OpenDaylight are the two obvious kind of big ecosystems where if we can build an implementation of this and prove that it works and demonstrate the value, we think we can start kind of a network effect to push lots of controller-based things to use the common interface. So the Boulder project then dovetails with the Atrium Enterprise and the universal communications use case. We're building in Atrium Enterprise to support the internet first and the WAN offload use case that Gert just described. We're building that system in OpenDaylight using the intent-based networking interface from the ONF inside of what they call the NIC project in OpenDaylight, the Network Intent Composition Project. So Enterprise Atrium will come out supporting that use case and based on this intent-based approach.
Thank you. So in Centennial, we are focusing very much on on wireless transport networks, and in those wireless transport networks, it's essential to make them SDN-like. That first of all, a southbound interface needs to be aligned between the different vendors. So we are currently focusing really on a southbound interface on netconf young. For all the vendors who participate in our project. And this is a key enabler for SDN solutions at all, because in the current system or in the current networks, it's multi-vendor network is really complicated to integrate different solutions of those vendors with their proprietary management systems in multi-vendor networks for the service providers. And by doing so, the idea is that we can save a lot of energy and resources with a common interface to the microwave and millimeter wave boxes, because the integration will be much more faster and will give the opportunity to the service provider to buy more equipment and instead of spending all the efforts in integration of some of those equipments. By doing so, we will use the ONF core model and put microwave extensions to it. They will be implemented currently in a mediator. So at this point in time, nobody touches really the network element software. We have a mediator, some call it adapter or translator in between, which is one opportunity to address also the legacy which is in field and will not be vanished in the near future, so that also those devices can be part of an SDN solution.
Thank you, Martin. So my next question is to Dave, if I may. So the NIC project, the Network Intent Composition, that project is pretty well known to the OpenDaylight community, right? But now there is the project Boulder. So could you tell us a little bit more about how you see Boulder working with NIC? And also why ONF and why not OpenDaylight as a good place to do the work?
Right, so I'll start with a second question. I think the ONF is really the only place you can do this kind of work because it's controller agnostic work. If we build something in OpenDaylight and say that it's controller agnostic, we get some resistance from the other controller projects, and essentially we need another layer of organization that sits above the controller projects and provides standards and open source software that work across SDN controllers. And so, if you look at all the existing standards organizations, none of them really fit cleanly into that, except for the ONF. And so I feel lucky to have found a place where we can do this work and have these great relationships with the various upstream open source projects. In specifically, what we're planning to do is to take a common Yang model that will be a ONF software artifact and live in the ONF open source SDN repository, at the beginning of the build process for both OpenDaylight and ONOS, first step is pull down the latest version of the Common Yang model from the authoritative source at the ONF, and then build that Yang model to create the NorthBound interface for the application on the controller. So while a lot of the work to realize the, what we call the intent engine, the system that understands how to kind of deploy things based on the description, that piece really has to be in the controller and is very platform specific, but the information model and the software Yang model of the interfaces is really the common piece that ties these together and guarantees that we get a common and interoperable interface. And then there are pieces of the intent engine that turn out to be fairly generic portable code, and so wherever possible we're trying to build common Java code that would live in the ONF repository and again get pulled down into each of those open source projects and any other controller-like project in the future that wants to comply with the common interface.
Thank you. So leading to you, Gert, with the next question. Since Dave's also driving the Atrium Enterprise project, so could you tell us what was, so serving in the customer advisory, right, and the use case that you described from Microsoft, what was the reason for you to look at SDN in general to address that use case, and why OpenDaylight in particular, given there are so many other controller choices, perhaps?
Yeah, so I'll take the question in that order. So we've been looking at a number of ways to categorize flows correctly in the network. So, for example, voice and video to be able to mark it in the correct way. So, a long time ago, we just did GPO because every device on the network was simply domain joined. So that's an easy way of doing it. Later on, we started to look at heuristics. Can we like fingerprint applications? Can we try to recognize voice packets? Can we try to recognize video packets? But with new codecs coming along like on a regular basis, with everything getting encrypted, it's kind of gets very difficult to do heuristic analysis or to do fingerprinting or deep packet inspection of the applications on your network. And then obviously there is something we can do on layer 4, so we can just simply look at like UDP port numbers that are used for voice and video. But keep in mind that inside Microsoft there's 220,000 people, not employees, but people in total that are all very technical. And by the way, everybody is an administrator on their machine. So we find all kinds of traffic that in the queues for voice and video that we don't want to see in there. So that's a long answer to say that the only way that we can tell the network what to prioritize in the correct way is by having the application talk to the SDN controller, and then the SDN controller talk to the network, which exact flow to prioritize, yes or no, and which other traffic all to ignore, by way of speaking. Okay, does that answer your first part?
Yeah.
And then the second question is really around why OpenDaylight. So just like every large enterprise, I guess we do have a lot of Cisco equipment in the network, but we do have also a lot of other vendors. So we do use HP, we do use Arista, we use Palo Alto, we use Fortinet, we use F5 load balancers. So it's not one uniform network. So that kind of, and we made that choice specifically because we don't want to be locked down into a certain corner by one of our vendors. It kind of gives us a better position to get a good maintenance and repair deal every year, for example. So if you want to have a controller that can talk to all these multiple vendors, you kind of need to look at something like OpenDaylight, right? So that allows you to be vendor agnostic and kind of allows you to have one single controller that can talk to the multiple environments. So, and then we looked, okay, obviously Microsoft is a software company, so we could take the decision to do it ourselves, but we are convinced that it's much more easier and we will be much quicker to where we want to be, and it will be much more scalable by working with the open source community, providing a use case, providing input, than if we start to develop this from the ground up. Yeah. So it's just a way of being more efficient and be more effective in what we're trying to obtain by providing our requirements. And then lastly, so it doesn't mean that we will be using OpenDaylight, but it might be a commercial release based on the open source right? So nothing prevents us from going with a vendor that uses the OpenDaylight or that uses a controller based on OpenDaylight and kind of adding bits and pieces to it ourselves. It will give us a head start and will kind of make us, again, more effective getting to where we want to be.
Thank you, Gord. So I want to change gear a little bit and talk about standards driving software, and typically, specifically, standards that has actually come out of ONF. So the SIM, or the Common Information Model, that ONF has been driving to build the data plane abstraction layer, right? So I understand, Kartik, that you have used that very effectively in your Transport SDN project, as well as Martin, you have. Mm-hmm. So could you give us a little bit of perspective how you are leveraging that and putting that into consumable software?
Yeah, sure. And even I'll take even a step back actually. I just mentioned upfront, like one of our objectives when we started the project was to have an integrated control. And we wanted to break down the silos, like domain-specific, vendor-specific silos, maybe layer-specific silos. But one thing we didn't want to do was replace it by controller-specific silos or even standard-specific silos, right? And that's very important to understand upfront. It's going to be a failure, like if you just pick up, let's say, analyze, for example, some OpenDaylight NBIs, and then adapt it and base it on that, base our project on that, so that you start excluding others. Same thing like what Dave Lenrow said up front. So we found it in ONF that we want to do something which is agnostic of the controllers, because all the controllers at that point when we started 2 years ago or a year ago this project had there some kind of information model in their guts, and almost every standard had information models. Right. So what we did is we were actually fortunate enough when we started to have folks who had worked in ITUT for 20, 30 years. We had folks who had done the TMF model, the key folks, not just folks who participated, but the key people who defined the models in TMF, and people who worked on the AS1 control plane. All of them come together in ONF, and that was very fortunate. And we said, okay, this is a great opportunity for us to sort of build a model or start with a model which is not from scratch, but which gets insight from all this work that was done before, but start off like with a common information model rather than anything which is specific to technology, specific to SDOs. So we did that, and the first thing we did is, again, but for this particular project, we didn't want to fall in the trap of actually getting into another standards, right? So we said all these models, one of the flaws that we found upfront was they all were network focused. All these models looked at the network, what the device did, what the network data plane should do, and the models were defined from that angle. So in Transport API project, the Snowmass project, in ONF, we looked at it from top down. We looked at the applications. We studied, we analyzed about 12 applications, which was contributed by the various operators and the users. And then we said what kind of information they are really looking for. What does the applications need? And then once we identified that kind of information, rather than build an information model from scratch, we took the core information model, which was already now being developed in ONF, which was more like an amalgamation of all these other SDO models. And we pruned and refactored it for this Transport API project. So it was actually in the ONF information model. We just hid out stuff we didn't need. We threw out the stuff the applications didn't need. And we developed what we call the Transport API model. Right? And we took that model now, and then rather than actually start coding it, we found, of course, the model was in UML. Then we heard the feedback from the developer community that, okay, we don't use UML, we need something we can consume. And we heard it many times, like in various forums. So we said, okay, we made a decision to go with Yang data model. We called it data schema. But rather than hand code it, we said, okay, because we want to follow an agile process, we said we'll write a tooling. So we wrote a tooling that takes the UML and generates Yang from that. Right? So by doing that, what happens is whenever the standards experts from various SDOs go and update the UML, with a click of a button, just run a small script, within 10-20 seconds I have the Yang schema. And the Yang schema is good if you're actually putting it in, say, OpenDaylight, which works natively with Yang. But we found a lot of controllers and NMSs didn't work with Yang. So and the flavor of the day was like REST JSON. So we again leveraged in Pyang tool and we customized it. And we took the Yang and we generated JSON based on RESTCOM schema, RESTCOM spec. So using that tooling now, you could get from the UML all the way down to the JSON RESTConf based on RESTConf. And then we went even a step further. We had some tooling, again, write some tools to take that JSON and generate Python stubs, server stubs. And we use the stubs to actually have a reference database at the back to actually test out the concept, the use case that we were trying. Right? So this had no controller in the back, and it was just a simple database stub and some client GUI. But by that, we could verify that whatever we are talking really worked, at least from the API point of view. Right? The logic was not there. These were shells, but we knew that this would work. And just because we wrote this tooling rather than actually hand code it, the moment like somebody would come up with a use case, we could quickly test this whole idea and see what changes to the model we could do, try out the model, see if something is missing, and go back in a loop. And we did that recursively like over like period of 6 months, so that we could come like with a sort of version of Transport API model or Transport API SDK. And we just released it yesterday. We released the version 1.0 of the Transport SDK. And now we are fairly confident, at least for like the common simple use cases, this API is going to work. So this is kind of the one method we followed out here. And by doing this, I think we think we found a way to bring standards into software.
Mm-hmm. Yeah. Martin, would you like to address that question as well?
Yeah, so what is valid for the Transport API is also valid for the wireless transport project. The only difference is that instead of a bunch of models in wireless, almost no standard model existed. So we had to choose something. And we went for the ONF core model because this is technology agnostic and it's designed for SDN. So it has a very low layer of LTPs, logical termination points, which is really from an SDN controller point of view a nice thing, because the SDN controller does not need to care about is it wireless or is it optical or is it packet. So it's very efficient to build on such model software. And then we added our specific microwave extensions to that model. So and we got already a bunch of tool sets. What Kartik also mentioned, there are tools available who translate the UML into YANG, and then with the YANG tools of OpenDaylight, it's very easy to add them to OpenDaylight, and you immediately have, by more or less one click of a button, southbound and northbound interfaces in an SDN controller.
Thank you, Martin. So let me just follow up a little bit on that question itself. Tell us about what was the key technical artifact that you produced as part of that project. And if the OpenDaylight community wanted to participate, what would be a good place for them to do that?
So the key why we chose OpenDaylight was really these YANG tools and the MD cell. Which it makes it very easy for for a model to have southbound and northbound interfaces. We are building or we are at the stage where we have just building blocks, the very basic building blocks. So we have southbound interfaces, northbound interfaces. We need to find a way to pass notifications through the SDN controller. So we are really on a very first level here. And OpenDaylight, everything was already available, and also the tool set from the ONF was available, which was very easy for us to have in a short time frame something which could be demoed in proof of concept.
So you sort of think that they could potentially work in that microwave mediator space?
Currently each vendor implements a mediator to translate their proprietary interfaces into a common interface. There you really need information about what is the interface of the vendor itself. But we also used open source for the mediator, for the netconf YANG interface, which was OpenHumor. And so in those areas, I would say it does not make much sense just to jump on it. What we see is that on the application layer, there's a lot of stuff which could be implemented, which is really useful in the future to build applications on top of a common microwave model, especially if it goes then later on in from wireless transport more into the RAN. 5G will be one of the key technologies in the future, and we see a lot of applications in that area.
Okay, thank you. Karthik, would you like to address that question as well?
Yeah, sure. So we have built the Transport API SDK, right? And this SDK, we have taken care, like I said, to make sure that it's extensible and it's fully extensible. So there's two ways folks who are interested can participate. One, if you want to be the Transport API provider, right? If you want to provide over the API, you want to provide some functionality, you could look to extend the Transport APIs to satisfy whatever you're providing, serving. And the other side is applications. And we believe that's the whole purpose of doing this. We want to see what kind of application innovation can happen in the transport space. So the applications, the software piece modules that would consume these APIs, right? And you can build, like, say, if you have, like, everybody talks about path computation, and everybody writes some kind of shortest path algorithm on top, and okay, here it is. But I know, like, out there are, like, real sophisticated algorithms that can be built on top in the simple path computation, and someone can consume the APIs and write these applications. Now, from the OpenDaylight community, what I'm looking for really is to have an implementation of this Transport API SDK on top of OpenDaylight controller, right? So you could have this OpenDaylight controller controls on the southbound, right? You could have a proprietary network elements and whatever you want. But once you build this SDK on top of the OpenDaylight, you can expose it, your controller platform, to all the application developers on all kind of applications. It could be orchestrations, it could be network service function chaining, it could be network on demand. There are all kinds of applications that can be written on top.
Okay, thank you. So going back to the interoperability and standards question, I think I'm pressing something here that I should not. So Dave, this question is for you. So you are obviously working at for the Atrium enterprise use case, right, with building unified communications as the application on top of the Atrium Stack. So why do you think there is a need for infrastructure agnostic intent APIs for integrating UC&C?
Well, I guess I would say I think there's a need for controller agnostic APIs for all use cases, and that's really, what we tried to build in the Boulder project was, not a multi-year waterfall style analysis of every use case in the universe and trying to anticipate every corner case, but trying to build a extensible framework that would allow us to spend the next 20 years supporting every different use case and special case. And so I think a big barrier to adoption of SDN and any innovation technology is the risk and the cost of trying something new. Today, if you want to switch from controller A to controller B, you probably need to invest millions of dollars in custom controller-specific integration and throw away the millions of dollars of custom integration you had with your previous controller. We're trying to move to a place where the description of what the network needs to do is portable across infrastructure, and when you want to try solution B, you don't change anything at the integration level. You plug in a different system, you see if you like it, and if you don't, you go back. And so I think we were very lucky to find a real-world customer that sees the value of SDN and OpenDaylight for this particular application, and so we went from a mode where we were kind of supporting use cases based on theoretical priorities to having a real priority from a real live, large-scale enterprise that wanted to deploy it. And so it just turned out that we wanted to start delivering intent-based networking, and we wanted to deliver a unified communication solution for Microsoft IT, and the two came together in this first release of Atrium Enterprise.
Thank you. So I'm going to take a quick breather here and see if anyone in the audience had any question for the panelist before I go to my set of questions.
This question is about where do we stand about the standardization of the east-west controller interface communication? Because I have heard that there are many things which are happening, but I was wondering if it is standardized or ONF is working on it.
We have a group that's fairly recently formed and fairly early on in the process of figuring out what we can do in that area. At the same time, at this OpenDaylight Summit, we're building and talking about building some solutions in that space. And again, at the ONF, we're really trying to figure out a new way to find that balance between standards and sort of agile development. And I'm not sure exactly where that line is gonna come down, but there's a session in the design conference on Friday on federation that's essentially talking about this issue. Similarly, for this particular use case, we felt that one giant distributed cluster with shared fate, which is essentially the scaling model and the clustering model for OpenDaylight today, is not going to work very well. If you have 50 branches and the brain is in one of them, and that branch goes down, the other 49 go with it. So we're building something in addition to the MDSAL, which I would call an intra-cluster communication mechanism. We're building inter-cluster communications east-west specific to this use case. And I think, again, we want to get some experience building these things in the real world before we decide whether to standardize or not, and if so, decide what to standardize on. But we're really trying to lead with what works rather than a theoretical concept and then go to the field to find out if it works.
Yeah, there is already something similar which we know in the IP world, like the BGP. So we have something which works there, so we can learn from that and make sure that that understanding like these domains are allowed to expose to other domain what really needs to be, not everything. So security will be important too.
Right, and I think functionally we need something very similar to BGP, but hopefully for SDN, the answer will be something lower complexity and using some of the newer technologies.
Yeah, the thing is like in the case of all these domains, in a domain, the controller has a global view of what is below it, or even above. But when we have many domains, do we want each controller to have view of all the domains in some rudimentary way? Or maybe the bigger global view should be at some particular place? All these questions have to be answered.
Right, and I think that's sort of the state of the art in research in the industry right now. We focused on how to build one domain that sort of works and are only just now getting around to figuring out how to interconnect them. There's some hard problems left to solve, I think.
So just let me add a few things. In ONF, we have the architecture working group, which is a little bit different from what we are doing. And they are dealing with these different aspects to this question, right? When we say east-west, Dave just talked about this cluster to cluster. Second thing is like east-west between two different, I would say, platforms, say ONOS and ODL. And the third thing is east-west is between businesses, right? There's business domains. So different aspects to the problem, and not all of them will have the same solution and the same architecture. So in ONF, in SDN, right, we in architecture working group, at least some of us, we believe that everything is north-south. And as long as you have a virtualized view, a domain can expose in simple virtualized view, maybe a single node view. It can hide information, virtualize it. That will work, but that works only in certain cases, right? It doesn't work in all of these aspects. So I don't think it's a one single solution. There are different aspects to this east-west. And the business relationships, the east-west business relationships, they cannot really be solved by north-south interfaces. But for example, you could have intent between two different domain controllers, or you could have like transport API where we allow like the virtual networks to be exposed. But that does not solve the business aspects of the problem, right? So the east-west could have the business aspects, and often like BGP and so on, like which focus more on the signaling aspects, which is a little bit lower down in the network. But we got to address these questions even up, like I would use the word now, orchestrator, which I was trying to avoiding, but it needs to happen even at that layer. And it may happen even at the higher layer, like BSS systems. Right? So this east-west communications is at different layers, and we got to scope the problem, and that's something which the ONF architecture working group is right now tackling. It's not ready yet, but we realized once the discussion started, we realized it's not like east-west is not it's not a problem with one aspect, but there are n dimensions to it.
Yeah, when you bring out all this complexity, it seems like very daunting.
Yeah.
So maybe you just focus on what is doable and then build on
Yeah,
that.
yeah.
When you describe so many dimensions of this east-west.
Yeah. Yeah, it's very hard. And that's why at the API level, we focus on simpler aspects. But there is this working group which just looks at the architecture aspects, and maybe that's the right place to start. Mm-hmm. And then we start identifying the aspects and the points and saying, okay, this interface deals with this kind of problems, and then start developing the interfaces and maybe standardizing it. I don't know. Standardization should be the last thing in this. Mm-hmm. It's maybe more trying it out, exploring, and then go to standardization.
So I want to, if I may, quickly move to trials and proof of concepts and deployments with this work. So my first question is to you, Gort. So we're looking at the Atrium Enterprise, and we are talking about Microsoft doing a trial and a potential deployment in the future, right? So as an end user, what's top of your mind with this solution?
So when we look at the objective of the solution, Dave gets a phone call. Just kidding.
First time I've had the ringer on in my life.
Sorry. So the good thing, we can really look at a brownfield deployment. So looking at the solution, it will be possible to take a southbound technology or a southbound technique from OpenDaylight and kind of drop that into one single branch office. Or it can be a branch office, it can be one building in a campus environment, but we will place it in front of the WAN router. So that can be, or it can be an OVS switch that talks via OpenFlow to the OpenDaylight controller. It can be one of the other SD-WAN solution that we might be evaluating in the future. So it allows us, in fact, to do a POC, to do a pilot without impacting too much of that environment. So we don't have to rip out the infrastructure. We don't have to change much. We just add another box in the middle and we can kind of test it out. So we haven't made the exact decision where to go. The SD-WAN is a path that we looked at before. The disadvantages, they are all proprietary solutions. So they kind of lock us back into that proprietary corner where we do not really want to be. While if we plug in an OVS switch and we have it talk OpenFlow, it's kind of a open source environment. And then obviously, if we look at what's going to happen beyond it, so if it's successful, we're going to look at a larger scale deployment, then there's obviously more questions coming, like what about scalability, what about redundancy, failover, clustering, and that's things that Dave can address better than I do, so, and that's future.
Yep. Dave, you want to address that? So, with the Atrium Stack, you've been thinking about how to scale it out, right? And you have a session, so Dave has a session tomorrow to talk, give some technical details on that. It's at 3 p.m. tomorrow afternoon.
Yeah, 3:05 tomorrow, and we'll
3:05.
kind of talk in some detail about, the technical components and some of the changes we're making in the code to support this.
Yeah, but do you want to just give them a sneak peek sort of on what your thoughts are with a scale-out architecture with ODL?
Right. So I guess we sort of touched on this issue, but essentially I think most of the emphasis in OpenDaylight early on was data center. It's kind of a single location, and if you could build one giant cluster and keep it up most of the time, that was good enough. It's really when you go to these more distributed topologies and you have inner data center links, or you have a campus or a bunch of branches, that you have to start to ask the question, is there another way of scaling this? And again, I think ultimately the cluster model is an attempt to build something that will never go down. Modern network architectures are moving more to an anti-fragile kind of architectural approach, where you assume that everything will go down and you design it in such a way that it will, survive that. And so I think all those things come together and sort of explain why we're exploring this new sharing mechanism within OpenDaylight. The cluster, essentially everything shares fate, and it's really unlikely to get corrupted or go down, but if it does, everything goes down, and it's catastrophic. I think certainly in our use case in the Atrium enterprise, but I think in many, many other areas in the industry and in the OpenDaylight community, people are beginning to see that we need some way of having separate OpenDaylight domains that share nothing and continue working perfectly when kind of the global store goes down. And so that's really one of the things, the campus-based use case here made us deal with that issue immediately. And in the short term, what we're going to do is solve it for the NIC project and for this use case, rather than try to solve it for the platform or sort of push to have this be a core capability of OpenDaylight immediately. We're going to try to get some mileage on it and get some adoption of it, and then try to, in parallel, we're having some conversations at the Design Summit with other stakeholders that need this functionality to figure out how we're going to build it. The current conversation is sort of, does it make sense to try to extend the MDSAL to support this other type of sharing? And if we do that, have we brought back the shared fate problem all over again? And do we need a separate solution for intra-cluster to ensure that they don't share fate in some subtle way that we don't see, which causes them to all go down collectively?
Okay, thank you. So if you want to find out more about the technical details, I guess come to the afternoon session tomorrow, 3:05 p.m. Martin, the next question is for you. So tell us how the project Centennial, how are operators involved in it, and what type of proof of concepts you are doing with this project?
Yeah, so we had our first proof of concept exactly 1 year ago in October 2015. So at that time, we demonstrated at Telefonica, so the first proof of concept was hosted by Telefonica, that different vendors, NEC, Huawei, Ericsson, SERE, Ceragon, that they are able to work together to find a solution. And the solution was simply that when the microwave signal degraded, the Ethernet controller or the Ethernet switch is informed and should do a reroute. So already in the first proof of concept, we had multi-vendors and multi-layer applications available. The second proof of concept was in April of this year. There we had a more advanced model, which we tried to demonstrate that it really works, that it can be implemented in those mediators, and gives functionality to an operator. So we had different compare application, which compares really the information from the network with planning information. Still in transport, planning is still a topic. So before something needs to be deployed, it needs to be planned and ordered. So you usually have a planning database, and later on you need to figure out if the planning is really in the network or if something was changed. It's a big topic for service provider to get track of those information. Of course, we showed topology information. We had an event application which simply just dumps all the events sent from the devices to the controller. In October this year, we will have our third proof of concept, now hosted by AT&T. And as you heard in the keynotes today, AT&T has its eComp concept. And the idea here is by AT&T to bring some application into the eComp for microwave. Currently, microwave does not play a role in eComp. That should change, and we will demonstrate with our applications in 1 month that microwave SDN is also able to play a role in AT&T eComp.
Thank you. Kartik, so a big interoperability event is going on, I believe, right now with the work that you've done with Snowmass. So tell us about that.
Yeah, okay. And just so I'll say, we had our first interoperability in 2012. It was a joint ONF OIF interop, and that time we didn't use the word transport APIs. That time the focus was on the OpenFlow and interoperability of OpenFlow with legacy protocols like TL1 and like ASON GMPLS. But during the interop, we also had this APIs which the controller exposed to the NorthBound. And as a learning exercise from that interop, we realized that that's kind of the place where we should be focusing on the NBIs. Right? We didn't want to use the word NBIs for a different reason. So we went back to the drawing board after that interop, and we developed this spec in ONF, and then we implemented the SDK. And now that SDK is being tested, and this is a joint activity between ONF and OIF. And there are about 5 carrier labs worldwide and about 10 vendors who have signed up for it. Right? And we are under NDA, so there's very limited stuff I can talk about right now. But the names and of the carrier labs and the vendors were released recently. And this is a worldwide interop. That is, this is real. There's real optical equipment, and there's real working, I would say, hardware, software, controllers, and systems. And the applications too, like, are actually real, like packet congestion monitoring, NFV orchestration, and so on. And these are actually being tested right now as I speak. So, and we'll probably have some press releases by end of this year or early next year on these results. Mm-hmm. So that's one thing, and that's the interop that you mentioned. There's also another activity which I would like to talk about, mention briefly, is we are collaborating with MEF, and MEF, at least a couple of projects have decided to adopt TAPI. So they're going to take up this transport API, and they're going to build their extensions, they're going to prune and refactor it for their purpose. The key point is this sort of illustrates the collaboration that's happening between these SDOs. And once that happens, hopefully going forward, we don't have like MEF API and then ONF APIs and ITF APIs and so on, but we have like at least some common industry standard. And then yes, there'll be MEF extensions, there'll be OIF extensions, there'll be ITF extensions. And if you want to consume the extensions, yes, you have to get certified by the right organization, but the base platform is going to be the same. So I think these are the two activities like I would sort of highlight. So second one is not yet an interop, but I think MEF is targeting a hackathon in November, which is going to be using this transport API elements.
Yeah, thank you. Any other questions for the panelists before we wrap up this session?
Yes. Any case study about interaction of ODL with the ONF controller? One for IP and one for optical, because for multi-layers, I see only one controller. For internet or transport, I don't see the case when one IP controller and another optical controller working together.
Yeah, there are actually use cases both. You said ODL, but I would say in general, yes, there are use cases both. We have found out like when we are doing the MEF as well as the OIF interop. So the transport API basically is an SDK. We looked at various use cases, but it's pretty generic. It doesn't mean that this is the only way you deploy it. But the actual deployment is going to be done by the cases. So in the OIF, the use cases are actually having separate packet controllers and separate optical controllers. And in some of the MEF use cases too, there would be like two different controllers and it will be orchestrated on the top. So there are the cases, but again, I cannot get into specifics because of each of this is not really yet public and it's being developed. And this is going to be implementation, not paper documents. It's going to be a demonstration of this. Yeah. So yeah, there are, and again, it's not OpenDaylight specific, but OpenDaylight will play a big role because the whole thing about this is making control agnostic. So we expect some vendors to have OpenDaylight implementation, some vendors to have ONOS implementation, some vendors doing the proprietary NMSs. Making it SDN-like. Mm-hmm. So also I think Dave can answer it in some sense.
Yeah, I think that same answer, essentially that.
You're looking for a use case.
Yeah, we'd like to blur the distinction of which controller does this and how many of them are there and where do they sit and all that sort of thing, and get to a point where you can develop software without having to worry about that and kind of have those details be customer driven or use case driven or those kinds of things.
Because in reality, yes, we have to compete with legacy systems, so it's not a greenfield or any of these open source controllers.
Right. Yeah, I think if SDN visionaries were to design all this stuff from scratch, it would look very different than what we're actually going to have to do to insert it into the market. And but again, so I think that's another reason. If people say, well, we do that with 7 controllers, we say, fine, it ought to work. If we do it with 1 controller, it ought to work. We're really trying to leave that to kind of deployments and implementations and design the building blocks in a way where it shouldn't matter.
Anything else before we go? So for each of these projects, we actually have bi-weekly meetings, right? Bi-weekly engineering calls. So if you have an interest or if you just want to get a sense of where things are going, that would be a great place to sort of dial in and participate and see how you can be more engaged and even steer the direction of the project, right?
Right, so if you go to opensourcesdn.org and there's a kind of a trivial self-registration, and then you can go to the pages for the various projects and learn about the project. If you're interested in participating, the information about the weekly calls and the WebEx links and how to participate, all that stuff is online.
So if that's it, then that's really the end of the session. And that's
Actually, let me interrupt just to say one other thing that people may not know, which is that the open source SDN part of the ONF does not require ONF membership to participate in. So, it's not a question of whether your company's a member. If you're interested in contributing, come on down.
All right. Well, thank you for your time, and let's thank our panelists.